Let's see the optimal approach to some problem. So earlier we solved it in big of n square time complexity. Let's try to optimize that. Let's see how can we do that. So one thing we can observe here is, here our answer is 1 3, which is 5 6. 5 plus 6 equal to 11. We got our target. So if we assume in this way, right now we are at 6. We have 5 which is earlier already. So when we are at 6, if somehow we are able to remember that we got 5 already, our problem is solved. So let's see how can we do that. So see, we are at 2. So if we got 9 already, we got our answer. If we are at 5, if we got 6 already before 5, we got our answer. If we are at 7 and we got 4 already, we got our answer. And how can we do that? Let's see. Let's define a map to store the value and its index. The value is to check and the index is to store it in the answer. So how can we check it? So iterate from start to end. Right now we are at 2, and what is the number we require? How to find it? It is target minus nums of I, which is 11 minus 2, and it is equal to 9. Did you have 9 already? No, we don't have it. So let's move I. We're at 5. So 11 minus 5 equal to 6. So one more thing. Before moving next, we need to store in our map the key values 2, and we got it at index 0. We are at 5. 6. So do you have 6 already in the map? No, we don't have it. So what we will do is, at index 1 we got 5. Let's move further. So we are at index 2. So 11 minus 7, which is equal to 4. So do we have 4 already? We don't have it. So let's store 7. We got it at index 2. Next let's move I. So we are at 6. 11 minus 6, 5. Do we have 5 already? Yes, we have it. And we got our result. What is the index of 5? 1. What is the current index? 6. What is the index of 6? 3. So that's how we got our answer. So let's see how can we code it up. So these two are same. Let's define a map to store our number and its index. Hash map. Let's iterate in the array from first to start. So this is the required num. It is target minus nums of I. So see here, if our map has already that required number, we got our answer. Is key result of 0 equal to map dot get of required number and result of 1 equal to current index. And we can break here. Again we can return our result. But what if we don't get the required num? Simple. So if we don't get our required num, just add that at the current number, which is nums of I, and we got it at index I. Just that's it. Yeah, it is X. And what is the time complexity? At max we are iterating from start to end. It is big of n. And the time complexity to check in map is, it is big of 1. And this is also big of 1. Any operational map is, hash map is big of 1, so we don't need to worry about it. So this is big of n. So which is big of n? What is the space complexity? This is constant. What are the input? Yes. Let's see at max how many numbers map can store. See, what if we got our answer at last index? So we need to store all the numbers before that, which is n minus 1. Roughly we can assume it as n. So it is at max we need to store n minus 1 key value pairs. which is almost equivalent to n. So our space complexity will be big of n. So let's submit this. So there is some issue. Okay. So it is accepted.